Good evening, my dear students. How was your day? How is everything? How is the lecture, the test, and preparation for examination? Unfortunately, we have not met for a long time. And last 3 weeks, I demanded your class rep to schedule a day within the week since I couldn't meet up on Tuesday, but he failed to do that. So I deemed it fit that okay, since we have at least like 4 topics untouched or treated, I should do a video recording. I believe this may help to clear or to move forward. My name is Isa SN, that is Isa Stephen Ndalaji. I'm from the Department of Industrial and Technology Education, which all of you are aware, from Federal University of Technology, Minna. The course code of this course is IT 213. So today's topic, IT 213, Principles of Electricity. And today's topic is going to be electrical field intensity. Electrical field intensity. And look at it that most of what we have treated, they are just as a result of the combination after this have been done. Because the field intensity, the electrical field intensity, and the magnetic field, I think we have treated that even when it wasn't detailed in our 100 level. So I thought we should move on to some basic things to make many things faster. But my attention was drawn by one of your colleagues that I'm not following the course content. So that's why I have to go back to the first unit in the material. Though, even if this electrical field intensity is first things we are asked to talk about, it is never the first thing because there are some introductory parts, such as what is conductor, what is insulator, what is semiconductor, voltage, current, resistivity, and so on and so forth, which we have done that. So today we are going to be looking at electrical field intensity. And before then, there are instructional objectives. That is those things that you should be able to do after this lesson. At the end of the lesson, the student should be able to, one thing you should be able to do after this class is to define electrical field and electrical field intensity. You should be able to define electrical field and electrical field intensity. And when we talk about defining electrical field and electrical field intensity, I'm not saying you should give me word to word. I'm not saying you should give me what I give you. It's for us to understand what is electrical field. What do you understand by electrical field intensity? So you should be able to explain using your own understanding, using your own knowledge. You can make a lot of research about it. But based on this lesson, I'm going to explain it to you so that you understand and you will make an input. Also, you should be able to calculate electrical field intensity. There are calculations under this topic. So at the end of the lesson, you should be able to define electrical field, you should be able to define electrical field intensity, and as well you should be able to calculate electrical field intensity based on the available data. Now let us quickly look at some definition. That is the two definition of this electrical field or electrical field intensity. Now, the first thing we are going to define or we are going to explain is electrical field or electric field. So the space around an electric charge in which its influence can be felt is known as electric field. Let's quickly look make example of magnet. You know what magnet is. So when a magnetic material is brought closer to a magnet, it will be attracting the magnetic field. So at that point where the effect of the magnet is felt, from that point, that is what we refer to as electric field, though that is magnetic field anyway. But I just want you to understand what electric field is all about. So electric field is the space, is the area, is a field around any point charge, around any point of electric field. So is it anywhere, any area that the effect of electric charge will be felt is referred to as what? Electric field. The area, the jurisdiction, the surrounding where the effect of electric charge will be noticed is referred to as what? As electric field. And when we talk about electric field intensity, the electric field intensity at a point is the force experienced by a unit of positive charge placed at that point. Now, we said electric field is that area that is surrounded by that electric charge effect will be noticed. Now, when we now talk about electric field intensity, we are talking about the strength. We are talking about the rate at which the force, the rate at which another charge will feel the impact, will feel the force of electric charge. What does that mean? Is a measure of the force per unit charge at a given point in an electric field. Is a location, okay, is a force that an electric charge or another charge is experienced either by pulling or by pushing, either forward, positive or negative. Because when we talk about force, we are talking about pulling towards yourself, or you push away from yourself. So that force that another charge experiences within the field of electric charge is known as what? Is known as electric field intensity. So some textbooks, some people refer to electric field intensity as the what? As the electric field strength. The intensity of the electric field at any point due to a number of charges is equal to the vector sum of the intensities produced by the separate charges. Now, this aspect means you have a particular center. Let me call it a center. Let's assume you have a circle and you have a point, a center. That center is the electric charge. So the area that surrounds the electric charge is the field, as we have explained. So this field, other charges will be around it, other elements, other charges, other things will be around it. So there will be force, either pushing it away and create a distance or pulling it toward itself. So, but the distance will be, so from the main point where the electric charge is to any area that electric field force or the force of electric charge is being felt by another charge. Other charges could be numerous around the field, whether 1, 2, 3 charges, etc. So when after you calculated all these charges, all this electric field, it will now sum up to be the total electric field intensity. What I'm saying is that the electric field intensity of A, the electric field intensity of B, the electric field intensity of C, the electric field intensity of D. If you want to calculate the total amount of electric field or electric charge of a particular property, you are going to sum it up. A plus B plus C plus D plus this plus that, etc. Now let us quickly look at some points. When we talk about electric field intensity, say electric field intensity is a vector quantity. And when we talk about vector quantity, we are talking about something that have the magnitude and the direction, something that have a width, something that have a size, something that have an amount, and it have a direction. And it is denoted by letter E. So when you see any letter E, though other letters are used for another purposes, but for this course, letter E is what is electric field intensity. Then the formula is electric field is equal to, or electric field intensity is equal to F over Q. That is, E is equal to force over charge. Then the SI unit, force is Newton, while the charge is what? Coulomb. So it could be force divided by the charges, which is Newton per charges, or voltage per meter, because the meter aspect is the distance. Because there is no way we talk about electric field intensity without talking about the distance. And let us quickly look at this illustration. This is the main electric charge. So up to this point is the field. So the force that now push this particular charge may be somewhere here. But when it experiences a force, it pushes it to this point. So the effect of the force that this one experiences is called electric field intensity. And there is no way we will talk about electric field intensity without talking about the distance. So this R is the distance. So from here to here, it has a distance and it has a force or a charge. The Q is charge, while the R is distance. So now let us quickly look at the Coulomb's law. The Coulomb's law is equal to F, which is the force, is equal to K, constant of coulombs, then multiplied by the first charge, multiplied by another charge, then divided by, this first charge is like this one. When it pushes this one, then the distance it covers is this one, is this R. Then the charge it pushes away, that experiences the force, is this particular charge, Q. So divided by R squared. So from here, don't forget our E is equal to what? F over Q. Our E, which is electric field intensity, is F over Q. So if we now replace this F, we replace F by this formula, it will give us K this one divided by this, then divided by the Q. So when you inverse this division, this particular division, we end up having this. If you inverse this, this one is the division. Anytime you inverse the division, it will give you multiplication. So it will not be 1 divided by the new charges or charge. Therefore, if you cancel this, okay, this Q will cancel this Q. Then you will not be left with what? You will not be left with E is equals to K, because this Q, which is charge, has cancelled this charge. So you will not be left with K Q, which is the charge, divided by R squared. So that is our what? That is our formula for electric field intensity, or that is another formula for electric field intensity. There are other, our K is constant. Our K is constant, and this is the formula for the constant, and it could be given as 8.988 times 10 raised to the power of 9, or 9 times 10 raised to the power of 9, as the case may be, depending on the unit you are using. Then this E is known as what? Permittivity of free space. So for electric field intensity, E is equal to K, which is the constant, Q, which is the charge, divided by R, which is the distance, but the R is going to be what? Square. Or you use this formula, or we use E equals to F over Q. Let us quickly look at one example. Let us look at example. This example, what is the electric field intensity at a point P? The point P is 25 centimeter for a charge equal to 80 nanocoulomb. 80 nanocoulomb. Let's work the solution. This is the main charge, electric field. This is the point P. So from here to here, we are told is 25 centimeter. So this point, the charge here is 80 nanocoulomb. While this is the point P, then we have the distance, which is 25 centimeter. Note this N, which is nano. 80 nanocoulomb is going to be converted to coulomb, and this 25 centimeter should be what? Because when we talk about distance, we are talking about meter, so we are going to convert it to meter. Then the keys, the parameters that are given, we are giving R and we are giving Q. So our R, 25 centimeter, if it's converted to meter, it will give us 0.25 meter. Our 80 nanocoulomb, if it is converted to coulomb, will give us 80 times 10 raised to the power minus 9 coulomb. Then the formula we are going to use is E equals to K, Q, which is constant. Our Q is this, while our R is this one. When you punch everything together, you are going to get 11,520 Newton per coulomb. I believe we understand that. And let us look at another example, example 2. Two charges, 4 microcoulombs and minus 6.7 microcoulomb, are separated by a distance of 7 centimeters. What is the electric field intensity of a point P, which is 2 centimeters from the 4 microcoulomb charge? Now, what is this thing saying? You have a distance. This is one charge, this is another charge, and the distance is 7 centimeters. So from here to here is 7 centimeters. So this charge is 4 microcoulomb, while this point is the point P, which is this one. And the distance between first charge to second charge is what? Is 7 centimeters. So, but between first and second charge, we have a point P, and that point P is what? Is 2 centimeters from 4 microcoulomb. So therefore, we have our 2 centimeters. 2 minus 7 centimeters will give us 5 centimeters. And the total distance is what? Is 7 centimeters. And let us work it out. Now, note, the other time we talk about the total sum of a vector. So that means there is a charge here as well. There is another charge here. So this charge plus this charge, this one plus this one will give us the total charge. Now we have E total equals to E1 plus E2. E total equals to E1 plus E2. Now, E1 is equals to the formula. We all know this formula. Why we put 1, 1, 1 is for you to understand that we are dealing with this first charge. So don't be confused when we talk about this 1, 1, 1, 1, 1 of it. So we now have our R. Our first R for this particular one, you are dealing with this point P first, because the question says we should, what is the electric field intensity of a point P, which is 2 centimeters from. So we will first of all deal with this one. R is 2. Then if you convert it to meter, it will give us 0.02 meter. Then after you punch everything together, it will give us 9 times 10 raised power of 7 nanocoulomb. And let us work the second one. This is second aspect of it, which is minus 6. And so then our R is 5 centimeter, 0.05 meter. If you convert it, then if you use this formula, because note, our charge, which is this one, is equals to minus 6.7 times 10 raised power of minus 6. No, this time around we use microcoulomb, so it gives us minus 6. Then if you punch everything together, you have this 24 minus 24.12 times 10 raised power of 6 Newton per coulomb. Then for us now to get the total electric field intensity, we are going to plus this E1, this is our answer, plus this is our answer. Then if you plus them together, it will give us what? Okay, note, since we said is a summation, this E1 plus E2, but note our E2 is minus, so we put everything in the bracket, and note there will be an expansion here, or opening of the bracket, and if positive is multiplied by negative, it will give us what? It will give us negative, and that is why we have this negative here of minus. So 9 times 10 raised of 7 minus 24.12 times 10 raised of 6 will give us 65.88 times 10 raised of 6 Newton per coulomb, or we have a 65.9 mega Newton per coulomb, because this one is times 1 million. This one is times 1 million. So instead of using times 1 million, you can use M. You can use this as well. Believe you understand this. If there is any question in the future class, we'll be explaining it. Thank you for listening.